Imagine looking down at your dashboard and you watch the odometer click over to like 100,000 miles. For most people, that moment feels like a finish line. You start wondering if it's time to trade it in.
Oh, absolutely. You start turning down the radio just to listen closely to every little rattle.
Right, you're just assuming the engine is on borrowed time.
It is a massive psychological barrier. I mean, we are so conditioned by modern product cycles to think of 100,000 miles as the absolute twilight of a vehicle's life.
But what if that milestone was actually just a warm-up lap? Welcome to today's deep dive. Today we are taking you past the shiny marketing brochures to uncover the engineering secrets behind 5 legendary SUVs that just absolutely refuse to die.
Yeah, we're looking at a huge stack of automotive teardowns, mechanic reports, and engineering white papers that completely flip the script on vehicle lifespans.
We're talking about machines that treat 300,000 miles like a casual Sunday drive. And our mission today is to figure out exactly how they do it, because this kind of longevity, it really isn't luck.
No, it is highly deliberate. What we are really examining today is a specific engineering philosophy. Automakers are making very calculated choices to overbuild certain components.
Right.
And more importantly, they are designing these machines to anticipate human behavior. And by human behavior, I mostly mean human neglect.
Okay, let's unpack this, because looking at this stack of research, we kick things off with 2 vehicles that achieve this sort of mechanical immortality, precisely by assuming their owners are going to treat them terribly.
Exactly.
The absolute masters of the appliance approach to cars, right?
Yeah.
The Toyota RAV4 and the Honda CR-V.
Which is the perfect starting point, really. I mean, these are vehicles engineered for people who want to think about their car exactly as often as they think about their refrigerator.
You just expect it to work when you open the door.
Right, exactly.
Well, I love how the automotive analysis refers to the Toyota RAV4 as the cockroach of the automotive world. And they clarify that is the highest compliment possible.
It really is.
Like, there are documented cases of RAV4s running on oil that literally has the consistency of chocolate pudding, with air filters that look like they are harboring a small rainforest ecosystem, and they still fire up every single morning. How is that physically possible?
Well, the resilience comes down to what's happening under the hood. Specifically, Toyota's 2.5-liter 4-cylinder engine. The core philosophy there is reducing moving parts.
Because fewer parts mean fewer points of failure.
Exactly. But it goes deeper than just the quantity of parts. It's the tolerances. The precision with which these engine components are machined is so tight and the metals are so robust that the engine essentially leaves the factory already broken in.
Wait, already broken in? Meaning you don't have that period where the engine parts are grinding against each other, shedding microscopic metal shards into the oil.
That's it, yeah. A traditional engine often sheds a little material as the pistons and cylinders mate to each other during those first few thousand miles.
Right.
But Toyota's machining is so precise out the door that you bypass a lot of that early wear and tear.
Which ties perfectly into Toyota's practice of over-engineering the boring bits. I mean, they aren't throwing all their R&D money at flashy touchscreens. They are putting it into the stuff you never see.
Oh, totally. We're talking alternators rated for way more electrical amperage than the RE4 could ever possibly use.
And brake calipers that look like they were designed to stop a freight train. It's like they built this compact family SUV expecting you to tow a yacht through the Sahara Desert or something.
And that philosophy extends all the way down to the chassis, too. The rust protection on the RA4 is basically a masterclass in longevity. They galvanize the frame.
Which means they physically coat the raw steel in a layer of zinc, right?
Exactly. And zinc sacrifices itself to corrosion before the steel underneath can rust. Combine that with a multi-stage chemical sealing process, and, well, the results are incredible.
Especially in the Midwest, where winter roads are heavily salted, which is usually a death sentence for bare metal.
Right, but you can find 20-year-old RAV4s out there that still have completely solid structural frames.
It's wild. You can apparently open the hood of a RAV4 with 200,000 miles and one with 20,000 miles and almost not tell the difference. The timing chain keeps its tension, the engine mounts don't sag.
And the hybrid models actually take it even further.
Oh yeah, the electric motors in the RAV4 hybrid are entirely sealed units. Like zero maintenance. No belts, no fluid changes. You literally just drive it.
It's the ultimate realization of their design goal. The user physically cannot mess it up because there is nothing for the user to touch.
So, if the RAV4 survives by keeping you out from under the hood entirely, How do you engineer a car for someone who actually wants to do the bare minimum maintenance? That's the puzzle Honda solved with the CR-V.
Right.
If the RAV4 is the indestructible cockroach, the Honda CR-V is basically the golden retriever of the automotive world. It is just endlessly forgiving and always happy to see you. They literally designed it for non-car people.
Oh, absolutely. When you pop the hood, the oil dipstick is bright yellow and huge. It's just begging you to check it. And the air filter requires zero tools to change.
Yeah, Honda leans heavily into accessibility.
They really do. They know that if maintenance is even slightly inconvenient, like if you need a specific socket wrench just to check a filter, a huge percentage of drivers simply won't do it.
Right.
So removing those barriers is actually a form of longevity engineering.
Okay, I get that, but let me push back on this a little bit.
Mm-hmm.
If both of these cars, the RAV4 and the CR-V, are designed for people who view cars as mere appliances, does that make your engineering inherently boring?
How so?
Well, I'd like, where is the actual innovation if we're just making big yellow dipsticks?
What's fascinating here is that in the context of mechanical engineering, simplicity is the ultimate sophistication. It takes an incredible amount of innovation to make something this reliably simple.
Okay. There you go.
Take the CR-V's famous K-Series engine, for instance. It isn't chasing massive horsepower numbers. Instead, Honda uses conservative compression ratios.
Meaning they aren't squeezing the air and fuel as tightly before it ignites.
Precisely that. When you have lower compression, the explosions happening inside the engine cylinders are just less violent. Less violence means less stress.
And less heat, and less physical wear on the metal parts over time.
Exactly, and they combine that with massively over-engineered cooling in oil passages. They design the internal fluid dynamics so oil reaches the most critical moving parts the millisecond you turn the key.
Which explains why mechanics tear down CR-V engines with 200,000 miles on them and still find the original factory crosshatch patterns carved into the cylinder walls. I was reading about that in the source, and it completely blew my mind. The metal hasn't even worn down.
Yeah, those crosshatch patterns are microscopic grooves machined into the metal to hold onto tiny amounts of oil.
Oh, I see.
That way, the piston is always gliding on a thin film of lubrication. It's never scraping dry metal on dry metal.
Yeah.
And because Honda's oil passages are so well designed, that protective film just never fails.
That makes so much sense.
You see the same principle of elegant simplicity in Honda's real-time all-wheel drive system, too.
Right, because most modern AWD systems use complicated multi-clutch setups and electronic torque vectoring, which rely on like a dozen computer sensors deciding which wheel gets power, which just sounds incredibly expensive to fix when a sensor inevitably shorts out.
Yeah, Honda opted to completely bypass the computer. They use a simple dual hydraulic pump system right at the rear differential.
Wait, how does that work without a computer telling it what to do?
Think of it like a water wheel. When the front wheels start slipping, say, on ice or something, they spin faster than the rear wheels.
Okay.
That speed difference physically turns a mechanical pump, which builds up hydraulic pressure. That pressure pushes a clutch together, instantly sending power to the rear wheels.
And then what happens when you get grip again?
The moment the front wheels find traction and spin at the same speed again, the pressure drops and it goes right back to front-wheel drive.
That is brilliant. There are no sensors, no complex software code to freeze up. It's just pure fluid mechanics reacting to physical wheel spin.
It's purely reactive, and the components, like the fluid and the pump, are virtually bulletproof. So it's the exact opposite of boring. It's a masterclass in engineering restraint.
Okay, so if Toyota and Honda achieve immortality by building for utter neglect, the next two vehicles in our deep dive take a completely different path. Subaru and Mitsubishi.
Yes, they build for extreme physical environments and catastrophic conditions. Let's start with the Subaru Forester.
And I just have to say it right up front. Wait, when I hear Subaru, I immediately think of blown head gaskets. How on earth is this on the list of cars that never die?
It is the great automotive stigma, isn't it? I mean, anyone who knows cars thinks of the early 2000s models, which absolutely had head gasket issues.
Right, they were notorious for it.
But looking at the teardown data, Subaru engineered that problem out of existence over a decade ago by upgrading to multi-layer steel gaskets. It's a completely solved issue now.
Oh, wow, really?
Yeah. And what we are left with is one of the most brilliant powertrain layouts in the industry, the horizontally opposed boxer engine.
The flat four. They looked at 100 years of standard vertical engine design, where pistons pump up and down, and just said, what if we lay it on its side?
Exactly. And that decision alone completely rewrites the physics of how the car handles. Because the cylinders lay flat, the entire heavy mass of the engine sits incredibly low in the chassis.
which drops the vehicle's center of gravity drastically,
Yeah.
improving handling and making the SUV far less likely to roll over in an emergency maneuver, right?
That's right. But the real magic is what happens to the internal vibration.
Because the pistons are punching horizontally away from each other rather than jumping up and down.
Imagine two boxers in a ring punching each other's gloves at the exact same time with the exact same force.
Okay.
The impacts cancel each other out. That's exactly what the pistons are doing. They naturally cancel out each other's momentum.
I get it.
This self-balancing act reduces internal vibration so drastically that you have infinitely less wear and tear on the engine mounts, the bearings, the belts. You can literally balance a coin on the valve cover of a running Forester.
Try doing that on a standard V6. I mean, the coin would vibrate off in 2 seconds. And that low engine placement isn't just for handling, it's actually a structural safety feature too.
Yeah, in a massive frontal collision, because the engine is sitting down by your ankles, it's designed to drop down and slide under the passenger cabin rather than being pushed back through the firewall into the driver's lap.
It's engineered to act like a sacrificial roll cage. It is so smart.
Then you pair that engine with their symmetrical all-wheel drive system. Unlike the reactive hydraulic system in the CR-V, Subaru's is full-time. It actively sends power to all 4 wheels constantly.
And to handle that constant mechanical stress, they build the surrounding hardware with a level of redundancy that is almost paranoid.
Oh, yeah. The repair data notes that technicians routinely see Foresters with 250,000 miles coming in for their very first CV boot replacement.
The constant velocity joint boot, right? That rubber accordion-like cover that protects the joints spinning the wheels.
Yeah.
And they aren't even coming in because the metal joint failed, just because the rubber cover finally dry rotted after 250,000 miles of spinning.
Which is just incredible endurance.
Which actually brings us to our next extreme survivor. Here's where it gets really interesting, because we're stepping away from the family haulers and looking at a literal tank. The Mitsubishi Montero, which is also known as the Pajero globally.
This vehicle operates in a completely different paradigm. The Montero wasn't designed to survive a mall parking lot.
Right.
It is built on the bones of a vehicle that won the Dakar Rally, that grueling multi-week off-road endurance race across deserts and mountains, and it won it 12 times.
12 times. But I'm looking at these specs from our sources, and I'm honestly a bit confused. The Montero uses a heavy, thick steel body-on-frame construction and an ancient 4-speed automatic transmission.
It does, yeah.
We have modern SUVs with 10-speed gearboxes and lightweight unibody frames. So why would they put something so laughably outdated in a vehicle built for extreme survival? Doesn't that just destroy fuel economy?
This raises an important question, and it's the central tension of the Montero. It's the trade-off between efficiency and absolute invincibility.
Okay.
A 4-speed transmission is undoubtedly less fuel efficient. But think about the physical space. Fewer gears mean you have more room inside the transmission case.
Oh, so they can make the parts bigger.
Exactly. This allows Mitsubishi to make the individual components massive. The gear teeth are thicker. The torque converter is literally the size of a dinger plate.
The torque converter being the part that transfers power from the engine to the transmission, right?
Exactly. It's a fluid coupling.
Right.
Imagine 2 fans facing each other. You turn one on, and the wind from it spins the other fan. A torque converter does that, but with thick hydraulic fluid instead of air.
That makes sense.
By making it the size of a dinner plate, it can handle immense amounts of torque without overheating. It is cooled like it expects to tow a battleship.
So it's not a 4-speed because they couldn't figure out a 10-speed. It's a 4-speed because you simply cannot break those massive gears.
Precisely. And the body-on-frame construction follows the exact same logic. A unibody frame, where the body and frame are one continuous piece of stamped metal, like most modern crossovers, is lighter and gets better gas mileage.
Right.
But the Montero uses a ladder frame. That's 2 massive steel rails running the entire length of the vehicle. It is made of steel so thick that it takes decades for rust to even begin compromising its structural integrity.
So you have a vehicle that completely sacrifices modern fuel efficiency in order to survive the apocalypse.
Essentially, yes.
The teardown analysis also highlights the Super Select 4-wheel drive system. It's not a push-button electronic system that relies on a computer chip, but a legitimate mechanical locking center differential.
Yeah, you can drive it in 2-wheel drive on the highway, or lock the physical gears together for terrain that would literally leave other SUVs stranded.
And that analog nature is a crucial aspect of its longevity, isn't it? We often think of longevity just as not breaking down, but true longevity is also repairability.
Absolutely. You can find parts for a Montero and fix a Montero in rural Africa or Southeast Asia because it uses cast iron blocks and simple overhead cams.
Right. Try airdropping a modern luxury SUV into a remote village when it needs a software patch just to reset the oil change sensor,
Exactly. The Montero thrives because you can fix it with basic hand tools.
which is such a stark contrast to our final vehicle.
Right.
We've talked about rich heritage, we've talked about Dakar rally wins and decades of refinement. But how does an automaker buy its way into this elite club when its past reputation was, frankly, terrible?
Well, through brute force engineering and a sheer refusal to accept their own legacy.
The plot twist of our deep dive.
Yeah.
The Hyundai Santa Fe. Let's set the stage here for you guys, because 20 years ago, the name Hyundai was synonymous with cheap cars that fell apart. You bought one because you couldn't afford a Honda, and you just expected it to rattle itself to pieces on the highway.
It is arguably the greatest redemption arc in automotive history. I mean, Hyundai didn't just iterate on their old designs, they executed a nuclear approach to quality control. They aggressively poached senior engineers from Toyota and Honda. They poured billions into research and development.
Right.
But most importantly, they forced themselves to build a better car by issuing a 10-year, 100,000-mile powertrain warranty.
The industry analysis calls that a declaration of war on their own bad reputation. Because by putting that warranty out there, they financially held a gun to the head of their own engineering teams.
Yes, the cars absolutely had to survive. Otherwise, the massive wave of warranty claims would bankrupt the entire company.
And if we connect this to the bigger picture, they essentially reverse-engineered reliability.
Yeah.
They actively studied the engine failures of their competitors.
They did. They looked at why other head gaskets failed and decided to exclusively use multi-layer steel head gaskets. They looked at why rubber timing belts snap and destroy engines and switched to industrial-grade metal timing chains.
They basically took the weak points of every other engine on the market and over-engineered a solution.
Exactly.
And the transmission, too. I was amazed to read they actively avoided CDTs, continuously variable transmissions.
Which was a very smart move for a heavy SUV.
Right, because CVTs rely on a steel push belt sliding up and down metal cones to change gear ratios smoothly. If that belt slips or snaps under a heavy load, the entire transmission is just garbage.
Yeah. Hyundai completely bypassed that, and they also avoided the complicated dual clutch packs that make German luxury cars so incredibly expensive to fix.
What do they use instead?
They went with a traditional geared 8-speed automatic co-developed with specialists. They chose proven, solid technology and executed it flawlessly.
And it's not just the powertrain. They use galvanized steel in the undercarriage, where competitors still use bare, exposed metal.
Yep. They even engineered drainage points inside the door panels specifically to fight water and salt accumulation.
And they built the Santa Fe on the exact same platform as the award-winning Kia Telluride, right? Meaning the suspension bushings, the ball joints, the steering rack-like, all the components that take a beating from potholes. They're actually built to handle the load of a much larger, heavier, three-row vehicle.
It's the ultimate value play. You're getting the heavy-duty dependability of a CR-V, but with modern luxury features. Things like adaptive cruise control, ventilated seats, panoramic sunroofs that actually continue to work a decade later.
And you're getting it for thousands of dollars less, because the used market is only just now catching on to the fact that modern Hyundais are built like tanks. It proves that a company really can change its engineering DNA.
Absolutely.
So what does this all mean for you listening at home? We've looked at 5 completely different approaches to building an SUV that absolutely refuse it to die.
I think it means that true longevity is never an accident. You don't just get a lucky car off the assembly line. Whether it's Toyota's incredibly tight manufacturing tolerances, Honda's brilliantly simple fluid dynamics, Subaru's self-balancing boxer physics, Mitsubishi's massive gears and iron blocks, or Hyundai's sheer brute force over-engineering, they all share one thing.
What's that?
A flat-out refusal to compromise on the boring bits.
Yeah, it's a deliberate vendetta against planned obsolescence. They aren't building cars just to survive a 3-year lease. They are building cars to outlive your mortgage.
Exactly.
But, thinking through all this incredible engineering we've discussed today, it leaves me with one really provocative thought.
Oh, what's that?
So today we've explored how these SUVs achieve immortality primarily through heavy-duty mechanical engineering. We're talking cast iron engine blocks, massive torque converters, simple hydraulic pumps. Physical things you can touch, unbolt, and replace.
Right, the analog world.
Yes.
Metal, fluid, and friction.
Exactly.
Hmm.
But the entire automotive industry is shifting rapidly towards software-defined electric vehicles.
That's true.
We're replacing mechanical pumps with complex networks of sensors, proprietary code, and lockdown battery management systems. So what happens to this definition of forever?
That is a great point.
Like, will a 20-year-old EV ever be able to be wrenched back to life in a remote village by a mechanic with basic hand tools the way you can with a Montero? Or does the era of the buy it once and drive it forever vehicle simply die with the internal combustion engine?
That really is the ultimate question for the next generation of engineers. I mean, you can overbuild a physical gear, but software updates stop eventually. Can you code a car to be a cockroach?
Man, I guess we'll find out when today's EVs hit that 100,000-mile warm-up lap. Something to chew on the next time you look down at your dashboard.